Making a solo combat focused game means that you have two very important parts you need to absolutely get right. These are the two parties taking part in the fights. The first one being the player character and the second one is the enemies. In this devlog we'll be focusing on the second part, the enemies. We'll be discussing how to design a good roster of foes for a combat focused game, how to implement enemy AI using Unreal Engine, and how to polish these enemy characters to give them and your game a better look, feel, and most importantly, juice. So as always, let's start with the design. Enemies in combat-focused games are there to challenge the player. In the best case scenario, they force the player to think, strategize, and execute his strategy, all while having fun. Also, in the best case scenario, new enemies or enemy behaviors are introduced along the way to keep that loop feeling fresh for the player. Once the player understands how the current roster works and finds the right strategy to beat it, new enemies or behaviors are introduced to freshen up the challenge and keep the player engaged in the think, strategize, and execute combat loop. Challenging the player means pushing or forcing him to use the different abilities he has at his disposal, and most importantly, it means making him think about his positioning and timing when using said abilities. So the different enemies need to have behaviors that counter the player abilities, and vice versa. The player's character abilities need to allow him to face the different enemies and their behaviors. Therefore, when designing enemies, we need to take into consideration the abilities or type of abilities the player has, or will have if the player character is not yet fully implemented. So, my game, Wardens Will, has quite a concise gameplay. For the movement, the player can, well, move and evade. The player character uses a free character, free camera system, which means that the player is always facing the direction of the movement and does not strafe, which makes him fast and reactive. This means the enemy can be quite fast and aggressive as well. And since the player has an evade mechanic, enemies should have behaviors that challenge this mechanic. They can, for example, be able to swarm and surround the player to force him to escape, or have ranged abilities to launch projectiles at the player in order to force him to dodge. With a good variety of enemies, the challenge can be sustained by having the player face different groups of enemies every time. He, therefore, has always to think and strategize about what enemies should he eliminate first, what enemies should he stay away from, and what enemies should he rush and get close to. So now that we have the theory out of the way, let's talk about the concrete design and see what enemies I have designed for my game. By the way, Wardens Will is finally available for wishlisting on Steam. So if you are interested in the game, please go over there and wishlist it. That's the best support you can show the game at the moment. So if you are inclined to do so, the link is in the description and my gratitude is all yours. First, we have the minions. These are the normal enemies that spawn in numbers and can only perform one type of attack. There are mainly two different types with many variations for each type. There are the melee ones that will approach the player once they spot him and attack once they are close to him. And there are the ranged ones that will stay away from the player and shoot projectiles at him. There are different factions of minions, and each faction has its specificities. Goblins are fast and will chase the player if he tries to run away, and their projectiles are fast but don't have a very long range. Skeletons are slow but will swarm and surround the players, and golems will stay far away from the player and shoot slow but long-range projectiles. Second, we have the mini-bosses. These are slightly more evolved and dangerous than the minions since they have two types of attacks. A melee attack if they get close to the player, and a skill attack that they perform when out of melee range. They are bigger in size than the minions, have more health, and can spawn with the minions in groups to widen the possibilities and combinations of enemies. And last, we have the bosses. These are the heavy, dangerous foes that have a wide variety of attacks and can surprise the player with charges if the player is far away, skills if the player is staying mid-range, and different melee attacks when the player gets close. These are the biggest enemies in the game, are very tough to kill, and will spawn alone to emphasize the moment and have the player focusing solely on them. And before we jump into the implementation, there is one specific enemy that needs some real smashing. It is a very small one, easy to beat, but that can have a major impact, and that is that like button. So if you are finding value in this video, please hit that like button to show the YouTube game that you can think, strategize, and execute, and to show me that you like the content and that I should be making more of it. Implementing enemies in Unreal Engine requires implementing multiple different assets. First, we have the character class. This is the main class that represents the enemy actor. It is the asset that holds the capsule collision, the mesh, the animation blueprint, etc. I chose to have the enemy character class inherit from my base character class, which is the base class for my player, in order to take advantage of the features that are already present like health, damage, and inventory. And most importantly, this class has a gameplay ability system component, which means actors that derive from it are initialized with gameplay stats and can use gameplay abilities. Second, we have the AI controller class. This is basically the brain that runs the AI character. In it, we define what behavior trees to run, which is the logic our AI uses to make its decisions, and what blackboard to use for storing important AI variables, which is like the memory of our AI. We then need to create a behavior tree and a blackboard for our controller. And while most enemies can share the same blackboard because the things they need to remember to run their behaviors are about the same, behavior trees, on the other hand, can be quite different from one enemy to the other. Behavior trees are basically decision trees. The AI starts by performing some checks, which are called services, to find a target and measure the distance to that target and save that information in the blackboard. And then once it has that information, it will make decisions about what to do depending on the values of those blackboard keys, using what is called decorators. If the enemy is far away, it will decide to run towards it, which is done using the move to node. And if the enemy is close enough to attack, it will attack. And that's achieved using what is called AI tasks. Services and tasks are implemented as blueprints, and you can basically have whatever logic you want for gathering information and executing actions. You can, for example, have a service that picks a random movement speed to have the enemies running at different speeds, or have a service that picks a random number for executing a random attack from a pool of possible attacks. So since I am using the gameplay ability system, attack tasks just activate an ability using a gameplay tag. These gameplay abilities are similar to the player's gameplay abilities used for the weapons and skills. An enemy ability consists of 3 different assets: the gameplay ability, which is the main asset and which holds the configuration like the tags and which references the other 2 assets, the animation montage and the gameplay effect. The gameplay effect is the effect of the ability, mainly the damage done if it is a damaging ability, which is the case for almost all enemy abilities. When the behavior tree executes the attack task with a certain tag, the AI character will activate the ability that has that tag. Once the ability is activated, the animation montage starts. And in the animation montage, there are notify states for when the attack should make its effect. For melee attacks, it means performing collision checks to see if the weapon is overlapping a character, to then apply the damage effect to that character. And for range attacks, it means spawning the projectile that will apply the damage effect if it ever hits a character. And once we have all this configured, what we need to do is create the different enemies with their different animation blueprints, behavior trees, weapons, and abilities. Having a data-driven system like this makes creating a wide variety of enemies a lot easier than if we were to create each enemy as a standalone class. It also makes sharing abilities between enemies straightforward, since abilities are encapsulated and can be used by any character that has that ability. So with all that done, I spent some time creating the different enemies for my different factions, and was able to have a nice and varied roster of foes that worked really well together. Oh, this is not a bug. This is a feature that needs to be unimplemented. Or not. So let me know in the comments. Let me know if I should keep the enemies from being able to damage each other or not. Let me know in the comments. So, with a system like this, you might feel tempted to just keep creating new enemies and risk falling into the meandering depths of the infinite AI loop that never ends, and that keeps coming up with new enemy archetypes. So be aware of this and know when to pull out. In order to keep your sanity, because as we all know, AI is the biggest threat humanity will ever face, so don't be at the origin of humanity's doom. You might end up creating something that you cannot control. And once we are happy with our variety of enemies and their behaviors, there are 2 more things left to do. The first thing is balancing, which means tweaking the different values for each archetype to have a challenging and fun enemy to fight against. Trying out different speeds, different damage values, different projectile speeds, etc. This requires quite a lot of playtesting, and during these playtests, enemies should be fought alone and in groups of different sizes and constitutions to really see how the enemy behaves in all the possible conditions. And last but not least, polish. And as I've already said in previous videos, this is a crucial step that should not be neglected. It represents maybe 20% of the work that you'll do on the AI, but will probably end up being 80% of the fun. I've done most of the polish for my enemies and their animation sequences. It's just a nice way of managing your sound cues and particle effects. So I've made sound cues for my different enemies, and for their different actions like footsteps, grunts, growls, groans, for when attacking, taking damage, dying, and plugged those in the animation sequences along with some particle effects when needed. I added some trail effects to the weapon when attacking to add some more dynamism, and I also modified the material with a custom parameter that allows me to activate the emissivity of the material when needed. This is used as a hit marker when the enemy takes damage, and another visibility parameter that I use for spawn and death dissolve effect. This parameter is driven by a curve that is in the animation sequences and which is inverted between spawn and death animations. And just like that, our enemies are quite ready. Not finished, but quite ready. It is already very fun to fight them in different combinations and different groups, and it will be easy and fun to add some more variations and some more archetypes to the game. And that's it guys for this devlog. I hope you enjoyed it, and I hope you've learned some things along the way. As always, if you have any questions, please don't hesitate to leave them in the comments section. I will make sure to answer each and every one of them. If you've liked this video, please hit that like button, it helps the channel a lot. And if you're not already subscribed, please consider subscribing if you are interested in game dev and game design. In the next devlog, we will be updating the character and its abilities. We will be polishing the animations and the combat, and we will be creating new skills and new potions. So stay tuned. And as always, my name is Enes. Thank you very much for watching, and I'll see you guys in the next video.